webinar today. So I know everyone wants to get right into the presentation, but before we get started, I'm just going to go over a couple of housekeeping items. So right now, you probably noticed that everyone is on mute, and that's just so we can avoid background noises that may distract you from listening to the webinar. However, we of course do want to encourage active participation. So if you have a question, just type it into the question box at the bottom right-hand side of your webinar screen. We'll monitor these questions as they come in, and we'll answer as many of them as possible. I also want to introduce our speaker, Patrick Vinton. So Patrick is the CTO here at Analytics 8. He has over 20 years of experience in all aspects of BI rollout. He has worked in over 100 BI environments in every major industry and has co-authored 4 patents related to BI report development, SQL generation engines, and BI application server scalability. So with that, I'm going to go ahead and turn the presentation over to Patrick.
Thanks, Tracy, and thanks everybody for their time today. We're excited to kind of continue a theme that we've been doing when we talk about machine learning on our last few webinars, and that's to kind of remove some of the mystery around it. Today, we're going to talk about a very specific example using customer churn, specifically in the telecom industry. So we're going to start off with establishing and making sure it's clear the importance of customer churn and why it's very important to predict it. We're going to talk about how advanced analytics play a role in that. Then we're going to show you a demo, and then we're going to wrap up with some questions. So customer churn is important to literally every for-profit business out there, and actually even many non-for-profit businesses. When you lose a customer, that's called churn. And when you lose a customer, there's a direct loss of revenue associated with that. It's also important because when you lose a customer, you often need to replace that with a new one. And the cost of acquisition and all the provisioning and costs that are associated with that, that's most of the time is much more expensive than it is to retain a current customer. Also, in today's world of social media, there's also kind of a stigma out there when you lose a customer, especially in the telecom world or some sort of B2C model. You often run a risk of tarnishing your image out there in the social environments when you lose a customer. So in order to get a better handle and start to understand customer churn, there's a bunch of questions that we can ask. Some of them are, at a very high level. Who churned and why did they churn? When we introduce advanced analytics in this, we can start to look forward. We can say who will churn and why will they churn? Obviously, we want to know the impact on revenue, but then also a very advanced question that we can ask when we introduce machine learning models to our system is, what can I do about it? So you may have heard the term prescriptive. That's what we start talking about there. Is what happened versus what will happen, and how can I change what will happen or try to affect some behaviors. So that's kind of where these things look like on the spectrum when we're talking about churn. Now, churn is especially important for telco and many other B2C companies out there because the target market is massive. I mean, the target market is literally every single person out there. It's also interesting and very important because there's a lot of competition out there, and the competitive offerings are basically identical. So at the end of the day, when you go shopping for a telco, you want internet, and you're either going to get internet or you're not. Or you want dial tone, and you're going to get it or you're not. Now, obviously, there's some subtle things you can do by bundling things together, and of course, support matters. But all in all, that's the reason why churn is so important and such a big problem, and things, especially in the telecom world. So our goal today at a very high level is use some combination of traditional and advanced analytics to get a handle on this. We're going to be a little more specific as we go on, but that's really our goal today. So when we go to the demo, I'm going to be showing this demo in Click, but it's kind of important to say that what I'm showing today really could be in any tool out there, any sort of visualization tool. The goal here is really to kind of watch the process as you go from traditional to advanced and then mix the things together. The same thing goes with the machine learning algorithms that happen in the background. We're not really going to be going into much detail on that. In many cases, it doesn't matter. What more matters, at least for the subject today, is the process and the flow. That said, let's look at a dashboard, and this will look pretty familiar to you. This is kind of a typical executive level dashboard. It's got some few KPIs on it. Here on the left side of the screen, we see what's called a waterfall chart, and we get to see money in dollars on the left. On the bottom right, we get to start looking at our customers by counts. Both are important for different things. And by looking at these, we can see a very kind of grim story what's going on. We see that we have more customers leaving our customer base than are entering it. We see that both in raw counts as well as dollars. So those visualizations tell us that really quickly. And if you look at the numbers up here in the KPIs, the story gets even worse. As we can see right here, the value of the customers entering our system is less than the ones that are leaving the system. So in other words, we're losing high value customers and we're gaining low value customers. So we're going to come back to that a little bit later, but that's we can see not only is churn a problem, it's the people that are churning and the people that we are attracting are problems as well. So let's try to get a handle on that. So of course we need to get a level or two deeper. And so one way of doing that is to start looking at things sliced by different attributes and dimensions here. So on the left side of the screen, we've got dollars, and on the right side of the screen, we've got counts. The bottom, these tree maps let us know kind of share by whatever we're looking at. In this case, we're looking at by contract type. And at the top, what we see is what's called a distribution plot. And distribution plots are a common way of trying to get a handle on churn because it allows you to see a spread. So anything on the screen that we're looking at that is in that reddish color, those are folks that have churned, and everything in blue is people that have remained with us. And on the distribution, one of the things that you can really see at a glance is the spread. So the bigger the spread you see here, that means that it's less churning going on for that particular category. So we can see here, probably not very surprisingly, people who are on 2 years contracts, we see a pretty big spread here. So there's not a whole lot of churn going on in this category. And we can see that month to month, there is quite a bit of churn going on there because the spread between these two dots is very narrow. Now, is that to say that month to month contracts are bad? Well, for one thing, it's kind of just a way of life in telecoms. You pretty much have to offer the public month to month contracts if you're going to survive. So, but above and beyond that, we see that not all month to month customers are churning and are leaving with us. In fact, month to month customers represent the highest type of contract, the highest percentage contract that we have that is staying with us. So that means there's something else going on. It's not just month to month contracts by itself that's a problem. It's that contract type in concert with other things. So let's keep clicking around and seeing if we can see something else. So let's look at the different types of internet packages that are available here. So once again, we see a big spread between the blue and the red dots. So that means that our DSL customers are usually pretty sticky, but our fiber optic customers not so much. So obviously fiber optic customers aren't bad. I mean, we've looked at our benchmarks against the rest of the industry. We've got a good product here. That means there's something else going on. Maybe it's fiber optic plus something else. Maybe it's a customer support issue. Maybe it's a payment issue. Maybe it's a price sensitivity. We don't really know by looking at this. So, let's click around a few more times to see if we can find a pattern here. We look at payment method here. Some things that might be kind of obvious if you think about it. People that are on auto pay, which is this column here, in the last column, there's a very big spread between those. So those people that are on auto pay are very loyal. People that are manually paying online, we see pretty tight spread there. So there's a lot of churn going on there. Something that's a little bit surprising is people that in this data set, people that mail their checks in, they seem to be fairly loyal. So again, we don't really know this that's not to say we should go out and start marketing to people, say, hey, let's see it, fill your check. We're not going to manual online payments. That wouldn't make sense unto itself, but for sure we know that there's more to the story here. So what that means is when we try to understand why a customer churns, we can't just look at one thing at a time. In fact, we can't even just look at two things at a time like we're looking at here. We need to look at several things together. We need to look at how the attributes work in concert with each other to influence something, for in this example, churn together. And that's something that it's impossible to visualize. Even the most sophisticated visualizations that can only handle a small number of dimensions. But more importantly, the human brain can't wrap itself around multiple dimensions at the same time. And for sure, it cannot wrap itself around a very large data set and do things in bulk. Now, is that to say that traditional analytics is not valuable? Of course not. You know, we did find that a lot of interesting things so far, but so far we haven't really satisfied our goal of being able to isolate churn and figure out why. All's not lost here in our traditional. Let's go to one last way of looking at our customers. If we look at them based upon tenure, so if we look over here on the right, you know, the longer the customer's with us, it seems that that's the stickier they are. It's a little bit of a chicken and egg thing, but you know, if they've been with us for a while, they tend to stay with us. We look here on the opposite side of the spectrum, our new customers, we see a much different story. Here in the 3 to 6 month bucket, these two dots are basically on top of each other. So what that means is, as soon as somebody enters that bucket, somebody else is leaving just as fast. So we're just kind of spinning our wheels right here. And if we look over here at our brand new customers, the customers that have been with us from 1 to 3 months, we see it's even worse. We see the red dots actually above it, which means we are losing customers in this category faster than we are gaining them. And so for this, this is something that stands out on us, even using traditional analytics. This is a real big problem for us. Of course, we want to solve our churn problems elsewhere, but that's a different set of analysis for a different day. Today, we really want to get our handle on what is the profile of a customer that churns versus somebody who looks like they're going to be loyal between 1 and 6 months. And once we get a profile for that type of customer, then we're going to do two things. We're going to hand that to our product managers, the people who decide what the bundles look like and decide what the pricing looks like. And we're going to say, hey guys, with this information, you need to maybe refine our product offerings. And simultaneously, we're going to give the profile of that person to our marketing department and say, hey, marketing, this is the profile of a person who is going to be loyal to us. Make sure this is who you try to market to. And when you figure that out, work with product management to see, once we have identified them, what are we going to offer them? So once again, real succinctly, we're going to try to figure out the profile of people who are churn and loyal, who are new. So we've already talked about how we can't really do that with our own brains, but what we can do is use a machine's brain and then machine learning. Now, machine learning isn't magical. Basically, all you are doing is passing it data, and it is looking for patterns in that data, and then it spits something out. More specifically, in this case, when we were trying to predict churn, it's passing us the data back that we gave to it, and then it's adding a couple more fields or columns to that. One of the fields that it gives us, which is the most important, it gives us some level of confidence that that person is or is not going to churn. Now, typically that number is between 0 and 1. Sometimes it's -1 to 1. It could be however you define it. But for the sake of this example, it's between 0 and 1. And the closest you get to 1, that means the more likely that the machine has predicted that person is going to churn. Now, depending on the tool you're using or the model that you've written, also that comes out with that output is a reason why. And if we can start seeing patterns among those reasons, this is how we can start creating our profile, which, remember, that's our goal here today, is to find the profile of people that are going to churn and the profile of people who are not in our newest customers. So now that we've got these two columns in our data model, how does our dashboard look? Well, now this looks a whole lot similar to what we saw before. We see the waterfall on the left, which is dollars, and we see counts on the right. A couple big fundamental differences. The biggest of which is no longer are we looking backwards at what happened last month. We're actually looking forward and predicting what happens next month. We'll return with the data with some level of confidence. So we can actually expose that as a slider here in our dashboard as one example. And as an executive, I can start doing what-if analysis. So what if I'm feeling very optimistic and I want to say, if a customer's got to be, 83% likely to churn before I'm actually going to predict that he's going to churn, at least as far as my what-if analysis. Or maybe I'm very pessimistic and I want to do this, I say if he's a third likely to churn, I'm going to go ahead and assume he's gone. So this gives us the ability to do what if. Just kind of as a sneak preview and to kind of drive the point home, we don't have to do this just for customers that are churning. We can actually do it for the opposite customer, the customers that are entering our system. And so when marketing sends out something to somebody, they're going to score a person beforehand based upon their likelihood to respond to this campaign and ultimately become a customer. So while sliders are cool and what if is very powerful and gives us a lot of information, it doesn't really get us to that goal of figuring out what the profiles of our customers are. So in order to do that, we're going to have to go a little bit deeper and start to look at the reasons behind, the reasons that the model kicked out. So we're going to go down, not quite to the lowest level of detail, but we're going to aggregate it up by a few things here. And now we're going to start looking for patterns. And if I sort decreasing by churn confidence, these are the types of customers broken down by this that are most likely to churn. And so we can kind of glance at this and we can start to see the reasons why that the model spit out. And we can start to see some patterns here and you say, all right, I've got it figured out. Well, before we get too carried away, you know, the first 5 or 6 lines look more or less the same, but we can see the numbers are kind of low. Oh, I've missed a very important part, which is just to select our young customers. So we're not really getting the whole story there. You know, there's more going on there than just looking at this, because we got to look at the counts. Maybe we also want to consider value at the same time too. The opposite is also true. We can see no patterns. If we want to see our stickiest customers, we'll do a reverse sort on this. Man, we can't eyeball any patterns on this one. So we need a little bit of help. And where do we get help? Well, once again, we can turn to a machine learning model to get some help, figure out, to find the patterns for us. So when people talk about machine learning, often I'll only talk about predictions. Yes, it's good at predictions, but ultimately even what a prediction is, it's helping find patterns that you're not able to see yourself as a human being. So in this case, what we want the machine to do is, rather than spit out, you know, the granular level, atomic level detail and score each customer one by one, we want the machine to create groupings for us, and groupings that make sense together. So that's what we're going to have it do. And when we do that, what are we left with? So we've got some profiles of our most likely to churn customers, and we've got some of the profiles of the most loyal customers here. So this is something that we can actually take action on. This is something that we can send to product management and say, this is what, you know, the profiles you need to be considering as you develop new products and develop new plans. And also we can send to marketing and say, these are the folks that we need to be marketing to, and keep this in mind as you're doing so. So hopefully this was just we went down one path of questions that we could ask for there, but what else could we ask of our data? So, you know, the first bullet is the one that we just did. We did it a little more precise. We did it just focusing on new customers. But that already kind of begs the next question is, all right, we've given this list to marketing, so they're going to have their own list of people to send it to. Now, of those, who's most likely to respond? So remember that what if analysis where we had the slider on the left in blue, we could kind of start playing some what if there. But then even marketing behavior is going to be changed. How do we predict what if? And part of that question is more complicated. There's several components of that. Some of the components are, you know, what kind of campaigns should we hit them with? And should we hit them through email, through print, through social? How do we talk to these people in order to get them to respond to the product that we think we should? I don't know if you guys noticed, if we look when we look at the profiles of our sticky people, top 3 profiles, I don't know if they actually were phone only. They didn't even have internet. So as a product manager, that would be really interesting to me. That would say, well, what are these people actually doing? And I'd like to know, you know, maybe it's something for their security system. You know, who knows what they're doing? And we need to find out. And when we find that out, this is something that may change our pricing. This may be something that we change to our product strategy, et cetera. And that kind of leads us to another question is, how do we define a high value customer? So when we first started this analysis, we defined a high value customer as somebody who was giving us the most money. But as we can start to see, even though it wasn't our goal to define a high value customer, it should kind of pique our interest that hey, a high value customer isn't just somebody who pays us a lot. It's somebody who's going to pay us a lot and stay with us and give us a larger total lifetime value. So there's some balance between that. And all these questions that we just talked about, these are things that you could poke around for a long time in a traditional dashboard, and you may get close to the answers, but this is something that you're more than likely going to need a machine to help you out with. So let's kind of continue this. Let's not stop here. What are some other questions that we could have asked? So we know month to month is just a part of doing business. What do those people look like? We know that probably customers just don't decide to churn overnight. They're probably giving us some warning signs, and we can start looking for those things and we can get ahead of it. Some customers need some proactive attention. Price sensitivity, that's another thing that's a really, really common use case of machine learning. But what we're getting at here also is, it's not just the questions we can ask of our current data. Sometimes we ask questions where we actually need to enhance our data. Now, this is true with traditional analytics too. I mean, 100% of us on this call have been working at some point in our lives, in our work environments, where we were asking questions and interrogating our dashboard. At some point, we hit a wall because we needed more data, or even maybe the dashboard itself needed enhancing. So, when we're thinking about customer churn in this example, one of these things is, when somebody left, where did we go? And that's kind of a fortunate thing in the telco industry is often we know where a customer went to, which one of our competitors did a customer move to. We don't necessarily know what package they're on or how much they're paying, but that would be an interesting thing to have in our data. And so as we go through these things, whether it's traditional or advanced or AI, that's something we should always keep in the back of our head. How do we augment our data to ask even more and more rich questions? And so with that, I think we're a few minutes ahead of schedule. It looks like we've got about 6 minutes for questions. Anybody have any questions about anything you've seen or anything else regarding, kind of mixing traditional and advanced analytics? Yeah, we had a question about what machine learning technology we used. While I was pretty careful to be agnostic on this, we do have some favorites here at Analytics 8. Of course, we could have done, rolled our own models and used R and Python. The ones that we use most often with our customers are, tools by Data Robot. Another one is called Compellin 2020. We like those tools because not only do they provide the models for us and automate a lot of the process, they also give us some rich metadata about it. So it's not just spitting out a confidence, it's spitting out a confidence plus a reason. So those are some of the reasons that we like some of those. So we had a question, how many variables do we typically feel comfortable using? I think he said you. I think we were talking about you as in a human being, not you as in Patrick Benton. Most visualizations can only handle 2 dimensions at a time, and maybe maybe a handful of metrics at a time, and that's really it. I mean, that's really the most that we can look at a time. And so I don't pretend to be an expert on those types on data visualizations and the scalability and portability of those. All I can tell you, there is a practical limit, just in my experience over the 20 years, that people can only see a few, 2 or 3 dimensions at a time. At that point, anything more, you need to use machine learning. So I said it before, but I'm going to go ahead and say it again. When we talk about machine learning or any sort of AI, it's not just about predicting. It's also about just finding patterns that you can't find yourselves, and patterns that maybe you didn't even know to look for. Now, does that mean that machine learning and AI is going to be completely autonomous? Absolutely not. The only reason we went, if you think about even this fairly basic example, we had to have a whole lot of domain expertise. We had to know which questions to ask to keep challenging our analytics and keep challenging our data to keep moving. Yeah, somebody pointed out a couple tools that I completely neglected. Yeah, there's Amazon machine learning and Azure machine learning. And yeah, those kinds of things are very good for doing binary classifications and spitting out a confidence. Some of the things where those tools are lacking right now is they're not able to do some of the profiling yet. I think that's probably coming. But yeah, we had another question about, what kind of horsepower do you need to run these models? Well, there's definitely not a single answer for that. I can say that the models have become more and more efficient. Now that machine learning is fairly ubiquitous, people are getting very good at tuning things. There's a lot of cloud providers out there where it kind of babysits that for you. There's also a difference between machine learning, which is done in real time, versus machine learning that's done kind of in bulk. So for this example, we were looking at things where the machine learning was applied to our data sets, we scored them, and then we analyzed it later. Now, there's a lot of other applications of machine learning that we didn't even talk about today, and that's basically, for example, a customer calls into your call center and you want to know right then and there why that person's on the phone, their credit worthiness. Or going back to our telco example or our customer churn example, here's a good one. Somebody calls in and they say they want to shut down service with you, and you've probably been in a situation where you're sent over to a customer salvage department. You probably didn't know that's what it was called, but that's what it's called internally at telco, is customer salvage. And they're doing a last-ditch effort to get you to stay. Before you've gotten to that point, and before they passed you over to customer salvage, there was a machine learning algorithm that scored you that basically says, are you low, medium, or high value? That kind of tells you how hard you should try to save this person. And the next thing that was scored in real time was, all right, now that I know I should try this hard to keep him, what do I actually offer to keep this person with me? So those are examples of machine learning models that aren't really made to run in bulk. They're made to score one-off transactions in real time. So that's a very long way of saying, for me to tell you what kind of resources you need, there's no really good answer out there, except for it's possible with most off-the-shelf hardware these days. The tools are getting smarter, they're getting more faster, and that's the good thing about everybody getting on the machine learning bandwagon, is there's a lot of attention on it now. So there's a lot of people also optimizing it. Any other last minute questions? Okay, well, perfect. Well, thank you everybody for your time. And Tracy, I'll wrap it up for you to, or pass it to you to wrap up, please.
Great. Thanks so much again, everyone, for joining us today. And thanks again, Patrick, for presenting. So just before we end, just a couple of closing remarks. So someone asked this question, but yes, we did record this webinar, and we will send the recording out in a follow-up email afterwards, so you can check that out or listen to it later or share it with anyone. So with that, I'm going to go ahead and conclude our webinar. Thanks again for joining, and I hope that you have a great day.